Assalamualaikum and hi to my panel, Puan Rosalawati and Dr. Sahazati. Firstly, my name is Siti Suryana binti Muhammad Fauzi. My supervisor name is CS Dr. Said Najib bin Said Salim. My title for bachelor degree project is Development of Brainwave Pattern Identification System for Brain Control Robot using Brainsense. So, I'm going to start my presentation project now. In this presentation, I'm going to explain 7 contents, which is introduction, problem statement, objective and scope, initial result, conclusion, and lastly, my project planning.
Introduction of this project. BCI, or we can say as Brain Computer Interface, is a technology that allows us to control a computer with our thoughts. BCI helps disabled people to communicate with their surroundings and improve their quality of life. BCI is defined as using electroencephalogram, which is EEG signals, to communicate with an electronic device exclusively through the brain. EEG does not read our thoughts, but it can tell our general state, like attention and meditation. It's based on the level of frequency and amplitude. Based from this project, the Brainwave control robot system is based on brain-computer interface.
Next is problem statement. Special needs people, specifically those who suffering from paralysis that limited their activity and functionality. Despite their limitation, these people still a lot to offer and can contribute to society. This is where the study is significant. By developing this brain control robot, it can be a stepping stone to become the model and visualize a future that unlocks opportunities and endless possibilities for these people. Interestingly, it also branched out the application towards IR 4.0 revolutions within industry. There are 3 objectives for this project. Firstly is to investigate the brain-computer interface. Secondly, translate brainwave data into robot movement. Third, to develop a more specific function of robot control by using brain-computer interface. Scopes for this project. Firstly is the results analysis for identification system is strongly dependent on Mindwave Mobile 2 and its MATLAB platform. The accuracy and persistency may be affected by the EEG sensor, sensitivity as well as the Bluetooth capability of the Mindwave Mobile 2. Third, the robot may have limited functionality focusing solely to demonstrate the brain control ability. Fourth, the robot design may change depends on the components used. Fifth, other software will use for the functionality test results. In the previous studies, in Chapter 2 for literature review, there are some identification system methods that have been listed, such as analyze data from MATLAB, analyze data from Brainwave interface, analyze data from LabVIEW. All the methods have already listed from the previous studies from the researcher. So, we can see that analyze data from MATLAB, the figure shown, the eye blinks data, and the second figure is raw data for alpha, beta, theta, gamma. Next is analyze data from Brainwave interface, also same as a MATLAB, figure MATLAB. Third is analyze data from LabVIEW. In LabVIEW, the researcher used LabVIEW to control the robot. They made the button for stop, forward, backward, left, and right. This is materials of types and models of EEG headset. There are numerous types and models of EEG headset existed nowadays. They are different with respect to each other depending on the function and performance. Most of the researchers will use the low-cost EEG headset for their research, such as Mindwave Mobile 2. It is compact and low cost. However, some of the researchers will use the different EEG device depend on their spec, such as emotive and others. Here is the system proposed. So we can see the figure there. In recent years, several feedback stimuli for a brain control robot and a brain control wheelchair have been proposed. So far, all of them are related to my research. Proposed system setup for methodology. It will start from brainwave signal and send data to NeuroSky Mindwave Mobile 2, and it will identify in the computer and pair it to HC05 Bluetooth module, then send to Arduino Uno, and it will detect to DC motor, which is it will make a move for the robot. This is the overall flow chart for this project. So it will start from Mindwave Mobile 2 request EEG data, and EEG data is sending from headset to computer. The computer process EEG data send with the MATLAB. Data will be classified, and next the Bluetooth module receive classification data from the computer and records it. The Arduino Uno receive data from the Bluetooth module, and the robot will move. Experimental setup for methodology project. There are 7 experimental setup. Start from apparatus and equipment, then software, Mindwave Mobile using MATLAB, circuit and schematic design, robot assembly, interfacing Mindwave Mobile with Arduino, and lastly analyzing waveform. So here we start from apparatus and equipment. So this is the apparatus and equipment need in this project. NeuroSky Mindwave Mobile, which is EEG headset, Arduino Uno HC05 Bluetooth module, L29N, 9V battery, jumper, breadboard, robot cases. Next is software. In this project, Arduino IDE and MATLAB software will be used. So Arduino IDE will be used in Arduino Uno, which is code for the robot, and MATLAB software will be used for the data analysis for brainwave data. Third is Mindwave Mobile using MATLAB. So in the previous study, single connector are needed to connect the NeuroSky device, which is Mindwave Mobile 2, to the computer, and it also important to connect in MATLAB, because in MATLAB we will use the single library, the special library for generate the brainwave data. Part is circuit and schematic design. So this is the proposed design that I already create in software, which is using software. So all the components have already connected in the software. Fifth, robot assembly. After done with the circuit design, the robot can be assembly follow the design. So all the components will be used to assemble the robot. Sixth is interfacing Mindwave Mobile with Arduino. Okay, after done with robot assembly, the microcontroller, which is Arduino Uno, should have connected with Mindwave Mobile to device. So it is important for this step to transmit the data from Mindwave Mobile to device to the Arduino Uno through the HC05 module. So once it's connected to each other, the next step can be proceed. Lastly is analyzing waveform. The waveform for brain signal can be observed and analyzed by the help of MATLAB software and application of NeuroSky headset. The identification system from brainwave can be developed by using the MATLAB software based on the coding and apps design that we use in MATLAB software. Hence, the waveform data in MATLAB will be collected for the result data.
Here are initial results for my preliminary results of this project. Supposedly, I need to start with my Mindwave Mobile 2 device exploration. However, there are some issues of international deliveries. But never mind. I already start with my development robot. So I already create the coding in the Arduino IDE, and I already use application Android, which is Bluetooth RC controller to control the robot movement. So the coding has been created and has been linked with the application, as we can see in this slide, which is I changed the code in case F, which is forward, case B for command back, case G for forward left, and case I for forward right. Next is the video shows the Bluetooth not connected and Bluetooth connected. So there's the different figure. So we can see the red button and green button. For red button, it will give the signal that Bluetooth not connected, while green button, it shows that Bluetooth connected. So the picture robot show that the Bluetooth already connected in the mobile phone. So therefore, the robot can be controlled by the mobile phone, which is to the left, right, and forward. Other than that, I don't have the initial result for my Brainwave Mobile 2, but I already test my Brainwave Mobile 2 connection with my computer, but there have some problems. However, I already know how to use this, but it needs more time to explore this device. So this is how we can use. There have the clipper that you can clip in the ear, and this one can be rotated like 90 degrees, and there are the brain sensor here to detect the brain signals. So this is how we can use. In conclusions, there are some problems were detected during the project development, such as connection and library for software. However, the problem can be solved by repeated tests for the project. In addition, there are limitations of the project due to the COVID-19 issues. There are no achievements for the objective of this project, but half of the objective 2 and 3 already conducted for preliminary results. Next, the focusing and timing for the development of this project should be more. Thus, it will be easy to achieve the objective and solve the problem statement of this project.
In future works, it will be continued, firstly with checking the connection for the circuit. Second, connectivity testing for Brainwave Mobile 2 with more than one devices. Third, interfacing Brainwave Mobile with MATLAB. Fourth, develop Brainwave identification system in MATLAB. Fifth, analyzing the brainwave in the MATLAB output. Sixth, connectivity testing for Moto and Bluetooth. 7. Interfacing Brainwave Mobile with Arduino. 8. Robot testing.
This is my project planning for BDP1 and BDP2. Okay, I think that's all for my presentations. For the question and answer will be continued in the next session with my panel, Puan Ruslawati and Dr. Sahazati. Thank you for watching.